Good morning, friends. Today we are going to see the next point from the topic superposition of waves, that is the laws of vibrating string. Friends, due to the COVID-19 epidemic, the state board have cancelled the 25% syllabus of the state board. So, in your class teacher will send the PDF of the reduced syllabus of the physics. So, friends, here onwards you should remember that the reduced part will not come into the examination, and we are also not going to teach that part. So, only the part which is important or which is coming in the examination, that we are going to teach in the notes. From previous topics we have completed the whole topic, but there also the part is reduced. So you should go through the PDF which will be sent to you by the class teacher. So that reduced part will not come in the examination. So you have to prepare in that way. Okay. So if you have any kind of queries or doubts, you can contact to the subject teachers. Friends, now we come to the point, that is the laws of vibrating string. Friends, here we will study the three different laws. Before that, we are going to see the formula for the fundamental frequency. The formula is N is equals to 1 upon 2L under root T upon M. So this is the formula for the fundamental frequency of vibration of stationary string, where N is equals to frequency, L equals to length, T is equals to the tension in the string, and small m is equals to mass per unit length. So the formula for the fundamental frequency of vibration of stationary string is given by N is equals to 1 upon 2L under root T upon M, where N is the frequency, N is the length, T is the tension, and small m is the mass per unit length. Now based on that, we'll see the laws. Law of length. Law of length, it means we have to indicate the relation between the fundamental frequency and the length. So what does the law say? The fundamental frequency, here I am writing only in the symbolical format, and you have to write in the format of the statement, and then you should write in the symbolically. So the fundamental frequency of vibration of the stationary string is inversely proportional to the vibrating length. I am again going to repeat. The fundamental frequency of vibration of the stationary string is inversely proportional to the vibrating length if, what is the condition? If T and M are constant. It means if the tension and the mass per unit length are constant. Again I am going to repeat the law. The fundamental frequency of vibration of the stationary string is inversely proportional to the length if tension and mass per unit length are kept constant. So this is known as the first law, or we can say law of length of vibration of stationary string. So it will indicate the relation between the fundamental frequency and length. So second law, law of tension. The law of tension, the law of tension will indicate the relation between the fundamental frequency and the tension of the stationary string. So here we have some tension in the string. So what does the law say? N directly proportional to root T. So the fundamental frequency of vibration of the stationary string is directly proportional to the square root of the tension created in the string if L and M are constant. Means if the length and the linear density are constant. We can call it the linear density or mass per unit length. Mass per unit length have a similar word, linear density. Okay, so what does the law of tension say? That the fundamental frequency of vibration of the stretch string is directly proportional to the square root of the tension created in the string if small l length and small m mass per unit length are kept constant. Or you can say if the length and linear density are kept constant. So this is the law of tension. This is the second law. Now the third law of linear density. So what is linear density? Small m, and you can observe that the n is inversely proportional to the square root of m. n inversely proportional to square root of m. So what we can say? The fundamental frequency of vibration of the stretch string is inversely proportional to the square root of linear density if, what is the condition? If L and T are constant. If the length and the tension of the vibration of the stretch string are kept constant. Again, I am going to explain this law, that is the law of linear density. The fundamental frequency of vibration of the stretch string is inversely proportional to the square root of linear density if the length and the tension of the vibrating string are kept constant. Friends, we can modify this formula. Note small m is equal to capital M upon L. Small m is equal to capital M upon L because small m is the linear density, mass per unit length. We know that the rho density is equal to m upon v, mass per unit volume. So m is equal to rho into v, and volume we can take as a pi r square L. So here we have got the value of capital M as a rho into pi r square L. So you can substitute here small m is equal to rho into pi r square L upon L. Here will get cancelled, rho into pi r square. So that is the value of small m. You can substitute here. So n inversely proportional to rho into pi r square. Out of this, rho and pi are constant, so we can get relation n inversely proportional to r. The fundamental frequency is inversely proportional to the square root of radius. Again, inversely proportional to the radius. Again, I am going to repeat this part. So remember, log will be completed here. This is the additional part. So small m is equal to mass per unit length. Now density rho is equal to mass upon volume. Mass is equal to density into volume, and volume is nothing but the pi r square L. So small m is equal to rho into pi r square L upon L. L will be get cancelled. So what is the remaining part? Rho into pi r square. This is the value of small m. So n inversely proportional to rho into pi r square. Now rho, density, pi, they are constant, and if we are taking the square root of the radius, so radius is a variable, so n inversely proportional to the r. So the fundamental frequency of vibration of the stretch string is inversely proportional to the radius. So friends, today we have seen the three important laws of the vibrating string. There is the law of length, law of tension, and law of linear density. I hope you have understood this part. Make the notes properly. Thank you. Have a nice day.